Okay, so let's talk about what to do with numbers that have exponents when we are multiplying them. So if we have a problem like 2 to the 4th power times 2 to the 2nd power, we see we have two numbers here that we're multiplying, each taken to their own exponents, and the exponent's telling us we're going to have to multiply these numbers, in this case is 2, several times, and then we got to multiply each of those by the other number that's being multiplied several times. So in other words, if we take 2 to the 4th power, what this means is 2 times 2 times 2 times 2. It means we're multiplying 2 by itself 4 times. That's part of the problem. This refers to this. And then if we take 2 squared, we're going to have 2 times 2. That's this part of the problem, because it means we're multiplying 2 by itself 2 times. What we're going to end up with is a total of 1, 2, 3, 4, 5, 6 2's that we have to multiply. That, as we know, when we're writing exponents, can be written as 2 to the 6th power. Let's take another problem. If we have 3 to the 3rd power times 3 to the 1st power, again, we can split this up into two parts. We can put a parentheses around this and a parentheses around that and kind of think of this as a two-part problem. So we can go, for 3 to the 3rd power is going to be 3 times 3 times 3. And then for 3 to the 1st power is going to be just 1 3 all by itself. And then when we see how many 3's we have, we see that we're going to have a total of 4 3's that have to be multiplied together, which can be written with an exponent as 3 to the 4th power. So we're starting to see a pattern here. We see that if we're going to be multiplying two numbers that are taken to an exponent power, and these two numbers happen to be the same base, we call this number the base and this number the exponent. If we're going to be multiplying numbers of the same base that are taken to the exponents, there's a shortcut we can use to figure out what these final answers are, instead of writing all the 3's and all the 2's out. So let's take a different number. Let's do 5 to the 4th power times 5 to the 6th power. This is a slightly bigger problem, and this is a problem where we can write it all out, and if we do, we're going to be writing a lot of 5's out, or we can use a shortcut. The shortcut we can see up here is if we have the same base, again, I have to keep saying it's the same base, because if it's not the same base, we would solve it differently. We'd have to write it all the way out like we did here. But since it is the same base, and we see here we have a 5 as a base and 5 as a base, we can look at the powers that are given with both numbers, and basically we can just add up those powers, because that's going to tell us how many of that base we're going to multiply. Here we're going to multiply 4 5's. Here we're going to multiply 6 5's. And so why don't we just say right now, right off the bat, that this is the same thing as 5 to the 4 plus 6 power, which is the same thing as 5 to the 10th power. Now, just to be sure, let's check that. Let's write this all the way out. We have 5 times 5 times 5 times 5. That's what 5 to the 4th power is equivalent to. And we know we're going to multiply all that too. Now, 5 to the 6th power, we're going to write 6 5's. Now we got 6. And then when we're solving this, basically what we just see a total of 10 5's together that all have to be multiplied. So we can just write that as 5 to the 10th power, multiplying 5 by itself 10 times. So this is just a shortcut rule that means that when we're multiplying two numbers that are the same base that are taken to an exponent power, we don't have to write everything out. We can just simply add up the exponents to tell us how many of that number we're going to multiply, and that will get us our solution, at least in terms of exponents. We'll do one more quick problem just to show how this works with really big numbers. You can do this with any set of numbers. Let's do 7 to the 108th power times 7 to the 2000 power. Now using our shortcut, we don't have to write out 108 sevens and then another 2000 sevens. Now we can just write 7 to these two powers added together, which would get me 2108. That number, by the way, is phenomenally huge. It's not a fun number to write out. It's easier just to write it out in terms of its exponents versus actually writing out what this equals, because it's a huge number.